right, you should have checked your answers here at this point from your homework. Do we have any questions, first of all?
Yeah, for each of them, when it's like the inverse, I just did a sine. That's all you had to do.
And that's fine. Because you're talking about the same angle, if you take the inverse sine of 4/5, you should get the same thing as if you take the inverse cosine of 3/5. And that could have been a way you checked your answer. You know, make sure these are right. Did you get the same angle? Okay. And remember, guys, I always want you to round your angles to 1 decimal point. Okay. Always round to the nearest tenth. Here's the bottom part of number 8. The tangent and cotangent both equal 1. Your angle is 45. You actually, if you were thinking, you could have figured this one out even without using the trig functions. Because if you have 5 and 5 and you're making a right triangle, what kind of a right triangle is that? Isosceles, okay? So if it's an isosceles right triangle, you know the angles are 45, 45. And then you have the 90, okay? So, don't forget about the stuff you've already learned in the past from geometry and earlier this year. So, all right, are there any other questions from your homework? Okay. What we're going to do then is we're going to get into expanding the ideas that we learned in the previous section to angles that are not acute angles. And I will take your graph plans later on. We'll get those. I'm assuming that's what the hands are for. Okay. So I'll collect those later on here. So if you'll get your notes here, we'll take a look at section 12.3. Remember, in the first section, we introduced our right triangle trig. Second section, we were looking at our 6 reciprocal functions. We also looked at our cofunction identities. We even saw the Pythagorean relationship between sine squared and cosine squared equaling 1, and then the variations on that. Okay. But here's kind of a common problem that we had been working with. You know, find the 6 trig functions of the angle in standard position through a given point. But every point that we've been given so far has been in the first quadrant. So how would we handle something like this, where theta is obtuse because we have this point negative 8, 6. I know that's small, but you can see negative 8 and 6 there. And of course, if you found the hypotenuse of this right triangle, you would have 10. So how does this relate? And can we actually do this? All right, you'll notice I labeled this angle here x. Well, can I use the x if I'm really trying to find trig functions of theta? And the answer actually is yes, as long as we pay attention to some different things. And that's what we're going to be looking at today, okay? As we draw obtuse angles or even angles that extend into the second or third quadrants, what we have is something known as the reference angle. The reference angle. The reference angle is an angle between the x-axis and the terminal side of an angle in standard position. So here, remember the initial side is the positive x-axis if we're in standard position. Our vertex is at the origin. We're rotating here. The terminal side goes through this point. So this angle right here, x, is what's known as our reference angle. Okay? Give you a moment to copy that down. Now, the reference angle is always going to be related either to the 180 degree angle or If we're in the fourth quadrant, it'll be the 360-degree angle that we're going to have to go off of. Because remember, like we mentioned here, it's always between the x-axis. A lot of times students want to take it from the y-axis, okay? We always go from the x-axis. So if we're in the second quadrant here, we would go up from the x-axis and find what this angle would be here, okay? We'll look at a couple examples down here and actually find some angles that have the same reference angle. Here's an angle in the first quadrant, a 30-degree angle. And what would the reference angle be here in the first quadrant? What's the angle between the terminal side and the x-axis? 30 degrees, that's right, okay? In the first quadrant, the angle is the reference angle, okay? However, there are 4 total angles in our 360 degrees that have a 30-degree reference angle. And of course, you guys know we could take more laps around and we could give more angles that have a 30-degree reference angle. But let's look at these 3, okay? We have a 30-degree reference angle right here, okay? So what would this angle have to be in order, and this is how you've got to think. You've got to think in terms of, all right, this would be 180. In order to stop 30 degrees short of 180, how far did I have to go? What angle would this be? Chrissy? That's right, 150, okay? A 150-degree angle gives us a reference angle of 30 degrees, okay? That extra 30 would have taken us all the way to the 180 degrees. So in the second quadrant, you're thinking, all right, it's 180 minus the reference angle will give us the angle that we have, okay? Any questions on that so far? All right. Now, what about we rotate into the third quadrant and we have a reference angle of 30 degrees? Okay? What would this whole angle be? Notice we've now passed the 180. So where do we end up? Alex? 210, okay? 180 plus 30 this time would give us 210 degrees, okay? So you'll notice in the second quadrant, we end up doing 180 minus 30 to get our 150. In the third quadrant, we're doing the 180 plus the 30 to get our 210, okay? Now, I would warn against trying to just memorize second quadrant, I subtract, third quadrant, I add. Just think, okay? We don't have to memorize here, just think. We know it's an angle between the x-axis and the terminal side. So look, where would that be? And then use that 180. Am I short of the 180 or am I past the 180? Okay? Over here in the fourth quadrant, we're not going off of the 180 anymore because our reference angle is now over here. We have a 30-degree reference angle. And what would this whole angle be in standard position to give us a 30-degree reference angle in the fourth quadrant? Nick?
Well, wouldn't it be, what would be 200 because it's 80 and then you add another 9. Oh, you add 90, that's right.
Okay, so what would it be? Well, that's all right. Let's think it through. If you went all the way around, how many degrees would that be?
260. Or you just do this one, subtract 30, and you get 330.
Exactly.
So, yeah.
330, okay? So, you guys catch that? If you went all the way around, it would be 360. We stopped 30 degrees short of 360. So 360 minus 30 would give us 330 degrees, okay? So you might be saying, big deal, okay? How does this all relate to our initial question of finding the 6 trig functions of an angle through a point, okay? Well, it relates because the values of the trig functions of each of these angles are related. And our goal here today is to look at how they're related. And what we'll find is that actually, if you know the sine of 30, you could automatically, without having to use your calculator anymore, you could give the sine of 150, the sine of 210, and the sine of 330. Without having to do anything more with your calculator. And it all goes back to the fact that they have the same reference angle. Okay? So, let's take a look at this. We just found these 3 angles here. And I want to do a little bit of calculator work here. So, let's see. James, could you find the sine of 30? Gabby, the cosine of 30. Abigail, the tangent of 30. And then Nick, the sine of 150. Alex, the cosine of 150. Haley, the tangent of 150. Jacob, if you could get the sine of 210 degrees. Ari, the cosine of 210 degrees. Aaron, the tangent of 210 degrees. And then Cal, the sine of 330. Chrissy, the cosine of 330. And Joseph, if you could get the tangent of 330. That worked out well. Everyone got one? Now, in your notes, you do not need to copy down this whole table. All right? I just want you to see something here. Okay? Those of you who like to write down everything, that's okay. But I want you to observe something here. We're going to make an observation, and we're going to use this observation to develop a rule. And the rule is what we'll write down. Okay? So, let's start here. Let's just rattle these off. You should have them by now. Think. James, the sine of 30? A half, okay. So 0.5. Cosine?
0.86, so.
Alright, good. So 0.866, and it keeps going forever. Okay. Tangent of theta?
0.58.
0.58. Okay. How about 150?
1/2.
Alex?
Negative 0.866.
Okay. Haley?
Negative 0.58.
Alright. Jacob?
Negative half.
Good. And Ari? Hang on. Did you do cosine of 210?
Oh,
Oh, you did 110? Okay. Alright, negative 0.866. Okay. And Aaron?
0.6.
Was it the 0.58?
0.577.
Okay. So 0.577, we'll round it the same as the others here. So 0.58. Alright. Cal, sine of 330?
Negative half.
Good. And cosine of 30? Okay. 0.866. And Joseph?
Negative 0.58.
Alright. Now, look at our numbers. What do you notice here? Remember, all of these have the same reference angle. Okay? So what do you notice here? Ari? Okay, all the sines, all the cosines, all the tangents have the same values. Alex?
The only reason there's negative and positive and the way they combine is because of the quadrant sign.
That's right. The negatives and positives are the only differences. And it's based on the quadrants they're in. Alright? And this is the rule that I want us to try to develop here. Okay? Let's see, what do you notice about the first quadrant? Nick?
There's no negatives at all.
There's no negatives at all. So all of them, okay, all are, R doesn't start with a G.
Gar.
Okay? Yeah, we're going pirate here. All positive, okay? What do you notice about the second quadrant? Harry? Okay, so which one's positive? The first one, sine, okay? So sine is positive, okay? And how about our third quadrant?
Only tangents positive.
Very good. Only tangent is positive. Okay? And the last one? Fourth quadrant? Gabby?
Only cosine positive.
That's right. Only the cosine is positive. Okay? So, if I know this, and by the way, this works no matter what the angle is. This is not just one special case. Any angle you get, if it's in the third quadrant, sine and cosine are going to be negative and tangent's going to be positive. Okay? Which if you think about it makes sense. Remember yesterday we said tangent equals sine over cosine? A negative divided by a negative is positive, okay? So, it makes sense that we get a positive tangent when sine and cosine are both negative, alright? But this works for every angle. If you know the reference angle, and you know the trig function for that reference angle, then you automatically know the values of the trig functions in the other quadrants, okay? Let's use, for example, a 45-degree angle, okay? You guys had this one on your homework yesterday. But the sine, well, let's use cosine. The cosine of a 45-degree angle is 0.707, okay? Cosine of a 45-degree angle is 0.707. So, just add one here. So, that's in the first quadrant, right? In the second quadrant, let's think this through. If I have a reference angle of 45, what would I be in the second quadrant?
135.
Very good, 135. So, the cosine of 135, remember we said only sine is positive in the second quadrant, right? So what would the cosine of 135 be? Negative 0.707. Alright? In the third quadrant, with a 45-degree reference angle, I'd be taking the cosine of, what do we have?
225.
Well, it's 45 past 180, so 225, okay? And what would the cosine equal then? The negative 0.707, okay? Third quadrant, cosine's negative. How about fourth quadrant? We're 45 degrees short of the 360. 315, good. And that's going to be positive, all right? See how easy that is? Okay? If you know your first quadrant, and then you know the reference angle, you can figure out those without having to use your calculator. In fact, and I think your book even still has this away in the back, if you look at the old trig tables, you know, they listed all the angles and they had sine, cosine, tangent across the top. They only went up to 90 degrees. Okay? They weren't going to list everything up to 360 because that was a waste of paper. That was a waste of time because with reference angles, you can figure out those other values. Okay? Using that trig table. Okay? Now, we're going to do more of this in a moment, but I want to get to our rule. Okay? Our rule is really easy to remember. You know, you'll notice here, all of them are positive in the first quadrant. Sine is positive in the second. Tangent's in the third. Cosine's in the fourth. I know we number them counterclockwise, but for this rule, we're going to go clockwise because ax makes a really good way of remembering what's positive in which quadrant. Okay? And I'd recommend even on your homework or on a test or quiz, just draw this on the top corner. And that'll help you remember, keep that in mind, what's positive in which quadrant. Okay? So all of the trig functions are positive in the first, cosine's positive in the fourth, tangent's positive in the third, sine's positive in the second. Okay? So that's a real easy way to remember what's positive in which quadrant. Okay? What?
Applying Bible class.
Sure. Okay? And that's easier to remember than astic or sact or something like that. So, ax works real well. All right, so let's think this through here. Okay? This is supposed to be a theta. We're going to do a couple of practices here. These are supposed to be thetas as well. All right, so I'll lock this in place so it doesn't erase. There we go. Pick an angle. 0 to 360.
359.
What?
359.
359. Okay, 359. 359 degrees. The reference angle would be what? What quadrant are we in? 4. So the reference angle is? 1. Okay? 1 degree. All right? Here's our angle. You can even sketch it if you want. 1 degree. Okay? That's the 359 degree angle. Okay? So, let's pick a trig function. Let's say the tangent. Okay? What would the tangent of 359 equal? Someone on your calculator?
Negative 0.017.
Negative 0.017. All right? So that works. Does it make sense? Tangent's negative, fourth quadrant? Yes. Okay. So, we already have the fourth quadrant angle. All right? Oh, I don't want sine, I want tangent. Okay? Sorry. I meant to leave those as blanks. So if we have tangent there, in the fourth quadrant, we already know it's 359 degrees, and the tangent is negative 0.017. Okay? So let's think about our other angles. In quadrant 1, our angle would be? It's got a 1 degree reference angle, and we're in quadrant 1. The angle is? 1. Okay? 1 degree. How about in the second quadrant? Second quadrant. I hear mumbling, I don't hear 179. There we go. We're 1 degree short of the 180 to keep us in the second quadrant. Okay? I heard some of you giving the third quadrant angle. That one would be 1 degree past 180. 181. Okay? And don't be afraid to sketch it if you need, okay? Here's 1 degree short of 180, that's the 179. Here's 1 degree past 180, 181, okay? Go ahead and sketch it so you can visualize it if need be, okay? So, if we know that this is negative 0.017 in the fourth quadrant, what's the value in the first quadrant? 0.017. Okay? How about the second quadrant? Negative 0.017. Okay? And how about the third quadrant?
0.017.
Yeah, there it's positive again. Okay? All right. Anyone have any questions about that one or anything in here? making sense so far? All right, good. Let's practice one more. And we'll do sine this time, so I don't have to rewrite those. Okay. All right, someone give me another angle, not in the fourth quadrant, and not in the first quadrant. Give me a second or third degree, or second or third quadrant angle.
150.
150. We already did 150.
114.
That's the same as 30. Okay, 114. We just did 150. All right, so let's think here. What would our reference angle be for 114? We're in the second quadrant, right? So how far short of 180 are we? 66. Good. Okay, 66. Again, visualize it if that's helpful. You know, 114 is going to be about right there. Here's 180. So what's this? Okay, you subtract 180 minus the 114. We got 66 degrees. Okay. So what's sine of 114? .9. Okay. We'll just leave it at that for here. When you're doing problems, don't round. Leave the whole thing in your calculator and round your final answer, okay? Because a little difference can make a huge difference in your final answer, okay? So we have 0.9. The angles here, in quadrant 1, what would our angle be? 66. And what would the sine of 66 equal? Don't use your calculators. What? 0.9. Okay, 0.9. And it's positive in the first quadrant, right? Okay, we already knew this one. It's 114. And it's 0.9. Okay, how about our third quadrant? A 66-degree reference angle into the third quadrant.
246.
What'd you say?
246.
246. Good. 180 plus another 44, 246. And what would the sine of 246 be?
Negative 0.9.
Negative 0.9, because we're in the third quadrant. Okay? And how about the fourth quadrant? What'd you say?
294.
294. You subtract 66 from 360, and we're at 294 degrees. So the sine of 294 degrees would be negative 0.9. Okay? So, this is why AX is so helpful, and these reference angles are so helpful, is because if you know one, you automatically know three others. Okay? In fact, when you guys get to pre-calculus, we learned something called the unit circle. Okay? And using the unit circle, you're actually able to very easily memorize the sine, cosine, and even tangent of 30, 45, 60, 90-degree angles, and then you're able to use reference angles to find all the ones in the second, third, and fourth quadrants too. Okay, and we use that a lot in our trig. Okay. Now, I'm going to collect your graph plans here in a minute, but I want to have you guys practice a few of these here. Page 566, written exercises 4 to 16, and then 45 to 51, the odds. This is already up on the blog, okay? Page 566, 4 to 16, and 45 to 51, the odds. Number 4 is just like ones we've done before, where you're given a point and you need to find the 6 trig functions. Okay? Numbers 5 through 8, for some reason, sometimes this confuses people. Just use your calculator. We're looking at quadrantal angles, which we haven't talked a whole lot about, but what's the sine of 0? Or the sine of 90? Or the sine of 180? Or 270 or 360? So it runs you through those. Use your calculator for them. And then, of course, it asks for the cosecant, secant, cotangent, so you're taking reciprocals, all right? But don't let that one confuse you. Use your calculator. You're not supposed to just know those off the top of your head at this point, okay? And then 9 to 16, they're asking you for reference angles. Getting used to looking at an angle, sketch it, figure out what that reference angle is, okay? And then the last section is a little bit of a, kind of a puzzle almost. They give you a value of one of the trig functions, and they give you some other information so you can figure out what quadrant you're in. For example, if I know I'm between 90 and 270, I know I'm either in second or third quadrant, but here I know sine is negative. Well, where is sine negative? In the third and fourth. So what quadrant do I have to be in? I have to be in the third, okay? And then I can also use this sine to help me construct my right triangle. Since sine is opposite over hypotenuse, when I draw this, this is my opposite, the -4. The hypotenuse always is positive, so you put the positive 5 there. And then you can use the Pythagorean theorem to figure out the other side. Okay, so it's a little bit of a puzzle. That's why I gave you all the odds. You can check your answers to see if you're getting it right, as you go. Okay, make sure you check them so that you can have good questions to ask tomorrow when you come back with those done. Okay? All right, that'll be it for today. If you'll get your graph plans out, we'll collect those.